in many situations in real life, you need to make decisions based on certain conditions. And that's going to be the job of what we call selection statements. Selection statements in Python are quite easy. You just like in real life. For example, you are dealing with the student passing mark. Let's say in our case in the university, passing mark is 60. So if the student mark is larger than 60 or larger than or equal 60, we'll say he passed. Else, what do you mean by else? That it is less than 60. So if it's less than 60, it is fair. That's a simple scenario where sometimes the computer make the decision for you. That's a simple case. Also for the air conditioning, if you set the temperature for 23 and the sensor at the room detect 25. So if the temperature is larger than 23, blow cold air. If the temperature is less than 23, blow warm air or do not blow air, and so on. So these are common scenarios where we apply conditional statements in real life. Now, how are we going to do that in Python? The syntax is quite simple, but before going into writing the code, let's learn a few basics. So the objectives of this lecture will use the selection statement. Basically, it is what we call if statement. A selection statement, or another name, if statement. So the job of the if statement is to make choices, to decide based on a certain condition, do a certain task or certain statement. Okay, so we need to apply conditional statements and to, let's say, come up with the selection statement. Loops, that's going to be the lecture 4 and 5, because we have two different loops. Today is lecture 3. That's going to be the focus on conditional statements. We'll use logical operations. Now in math, we have, the double asterisk, that's the power, multiplication, division, quotient, remainder, plus, minus. So that's what we call arithmetic operations. Now, here we're going to use logical operators, logical operation. And logical operations, there is a list for that. Logical operators, first, this is like asking, does it equal? Are they equal? Larger than or equal, less than or equal, and there is the does not equal. So those are the Boolean statements we deal in Python. Okay. So what is the output of these Boolean operations? For example, when you say A equal 5, B equal 6, C equal A plus B. What is the data type of A? It's integer. What is the data type of B? It's integer. What is the data type of C? It's also integer. Exactly. So what about we have this scenario? A equal 5, B equal 6. Then we said C equal A larger than B. So this is not an arithmetic operation. That's not math anymore. You just check. A equal 5, B equal 6. Is A larger than B? No. So this is what we call false. In this scenario, it is false. If it's not false, what will be the other option? True. And this is what we call Boolean variables. And Boolean variables has only two values, either true or false. That's not like numbers. And the data type is Boolean. So selection statements allow the computer to make choices based on a certain condition. The data type associated with these conditions is Boolean data type. So let's extend our data types foundation. Last week we did integers, we did floats, we did strings. Now we have Boolean. The good thing about Boolean, only two values, true with uppercase T and false with uppercase F. So the value of C if you go check the memory or the variable explorer, see is the data type will be Boolean and the value is false. So this is the name. Remember, every variable has a name, type, and value. We'll confirm that in a few minutes. Okay, so here are the logical or Boolean operators. So Boolean data type consists of two values, either true or false. So for example, here, this one reads like 4 does not equal 4. So this one acts like negation. Now negation not in the numbers domain, in the Boolean domain. So negation means if it's true, make it false. If it's false, make it true. So this one, initially I was checking with equality, but then you negated it. And now we will learn the difference between this and this. This is a Boolean operation, equality. You check equality. This one is the assignment operator. Again, it's no longer math. This is assignment operator. You evaluate certain something, certain expression, you get the result, assign it to that variable. Here, it's not assignment. You are checking two variables, and if they are equal or not. If they are equal, return true. If not, return false. To negate it does not equal. Okay, so here it reads that A equals B. Here, A does not equal B. For example, A and B. A less than B. A larger than B. Now, one important thing to notice, we know from, let's say, back in the day in math, this is less than or equal. But this symbol is not written in the computer. So it's written like this, less than or equal. Sorry, the opposite. Less than or equal. Like how it reads, less than or equal. This one is larger than or equal, or greater than or equal. Okay. Now, let's see the syntax of the if statement. The syntax is the way the if statement is written. So it is called a two-way statement. Two-way statement is basically you have a certain condition. Let me describe it in if you ever taken flow charts, it's something like this. You have a certain value, and this is what you have, the condition. And you either have true or false. No other options like that. So that's it. You only have two options. That's why they call it two-way selection statement. You cannot have true, false, somehow true, somehow false. No, it's only true, false. It's just binary. So here is an example here. Sometimes when we deal with problems in real life, for example, the area always should be positive. You cannot have a negative area. So someone wrote a code, import math. You are calling the math module. The math module has some functions. Let's say to find, like, you cannot write them straight away in regular Python, for example, the square root. So you input the area. The task here is to check, for example, to check the value of the radius. So we know that the area equal pi r square. So what will be the proper value for the radius? The radius equal the square root of area over pi, or pi, like this. Now we know in Python, there is no square root operation like directly, and there is no value for pi directly. However, from the math module, I know that there is the math.sqrt to find the square root, and we have math.pi to give me the pi value. So here you calculate the radius. First, if the area is larger than 0, to make sure that my area is real valued, something physically correct, then calculate the radius. Radius math square root of area over math.pi. And remember the division operator. Then print it. If the area provided was negative value, so that's physically incorrect. And then it will say print error, the area must be a positive number. And the syntax is simple as this. If, and you have the condition, along with the colons. Colons are very important. If you do not put the colons, that's a syntax error. You put a certain sequence of commands. No, it's not strictly one command. Like in this case, you write to calculate the radius and then print the radius. So this is the case if the condition is correct. Like if this value here, the condition returns true. If it, let's say, returns false, you still need to count the option that it is false. So you have to put the else statement. Else statement means that if this condition is false, do not execute those. Execute this part. So it will skip these lines. And that's why we call it selection statements. It selects one of these two statements or these two lines. So the else will be operated, and that's you have the sequence of commands there. So let's try this example here in Python. Spider. Okay. So let's write the code for the area equal integer or float input. You see that? Okay. Input, enter the area. And let's give it a new line. What does this part? When I execute this code, so I will write at the second line. I will not at the next line. I will not write immediately next to area. So for example, 5, that's it. So the area, the value is 5 and it is float. Okay, so let's apply the condition if area larger than or equal, it could be 0, larger than or equal 0. Let's not forget the columns. And the good thing about Spider, when you hit enter, it will automatically do this space. This is what we call indentation. And in Python, indentation is very important. Let's say, for example, you did not write it there, you write it here. Like the radius equal, I did not import math, so I'll go up, import math, area equal, the radius equal math dot square root of, we calculate it as area over math dot pi. Okay, so we calculated the radius. Now notice, like immediately the system is showing me that there is an error. And when you see this red circle with a cross inside, it means that that's a syntax error. It's no longer a warning. A warning is orange. Warning is fine. You can get away with it. But this one is an error. Code will not execute. Indentation. You have to give a space, let's say by about 4 spaces from the beginning of the line. It means that this code segment belongs to this if statement. So here, then you print the radius is, okay. And remember, that's another way of concatenation. We did that last week. Concatenation is to put a comma and you put the value R. If you are done and you want to include the other possibility where area could be negative, so you should say else. And notice the moment I put the colon, it did automatically, then it went back to the beginning of the line. It shows that now I'm no longer writing statements for the correct case of the if condition. Now I'm going to consider the other possibility, the else. So another printing statement, the area should be positive value or larger than 0. All right, I'm done. So let's execute the code, enter the area. So let's say 6, the radius is 1.3, whatever. Now let's write another statement. So let's clear everything, run it again, and let me put a negative value, -50. Well, the area should be larger than 0. So that's it. That's a simple if statement. Okay, so I told you that the result of this operation, the data type is Boolean. So let's view that in the example I did at the beginning. A equal 5, B equal 6, and C equal A larger than B. Now you treat the logical operators or the Boolean operators like they are operations like math, but their data types is a bit different than the mathematical ones. So let's see, A equal 5, B equal 5. I'm running selection. So A is integer, B is integer. Now let's see C. C, it's a Boolean data type and the value is false. Is it clear? I'll notice one thing, the size, it's 1. Even though it says here the word false, for example, D equal, let me write it as a string, false. You notice D and C, to us, they look like the same value. However, D, the length is, or the size is 5. That one, the size is 1 in Boolean. And they are totally different from each other. This one is just a Boolean operation, true or false. However, this one is different. That's a string. You can do several set of instructions for strings. Okay, from current slide. Okay. So in flowcharts, it's pretty much something like this. Here is your input, and you apply the certain condition there. If this is true, operate a certain sequence of statements. If it's false, another sequence of statements. They could not be working together. Like it has to be one of them. It's a selection statement. You select only one, let's say, path, and then you combine it back and you complete your code. All right. In some cases, there is no false statements. For example, if the weather outside is cold, wear a jacket, and that's it. There is no else statement in that case. So sometimes you want to check by a certain condition. They are unusual, let's say. They're not as usual as when we deal with numbers, we always take the full possibilities. But it says that the else part here is optional. You don't need always to have else. For example, in the previous example, in the code here, if I did not write this one, the code still functions fine. And if I put a negative value, it will not do nothing. So for example, if I remove this else part, what will be an easier way to remove this else part without deleting it? Make it as a comment. Remember, comments, single line comment, the hash. So this one, technically, I deleted them from the code. When I run the code, these parts will not be executed, the gray lines. So let's run. Okay, I put 50. It is fine. Run again. And I put -6. Nothing happens. So the code is fine. But sometimes it's always good to show the coder or the programmer that if that condition is not satisfied, show him something. Show that there is like a guideline, there a statement, just telling him that the value that you put is incorrect or something. So that's a case of one-way conditional statement. Okay, but I will not even actually call it one way. It's two-way, but the false part, you do nothing. Because here still you have an arrow going for the true and another one for false. So it is two-way statement. However, at the false part, you do nothing. All right. Now we said that the if statement is a two-way statement. But sometimes in real life, there are too many conditions that can apply to a certain problem. For example, the grade. If a student scores are more than 90, that's an A. From 80 to 89, that is a B. from 70 to 79, that is the C, and so on, all the way to F, less than 60. So how to do that in Python? The task is quite simple. First, you have to understand the problem that if I put F mark is larger than or equal 90, because 90 is still considered A. Print A. When I say the word else, what does that mean? Anything less than 90. So do I need to say that, oh, else if the condition is less than 90, do something? No. However, I still have to count for the condition that the mark is larger than 80. So it's like saying else if mark is larger than 80, larger than or equal 80, larger than or equal 80. So when I say this else part immediately told me that the mark now, if I reach this state, the mark is less than 90. So I don't have to put a condition to check if it's less than 90. However, I want to check if it's larger than 80. Now you notice like this else if, to make it, let's say, faster for typing and to make it easier for us, they combine it into a single keyword, elif. Elif means else if. So else if the mark is larger than 80, print B. Then elif. What does this elif mean? Now the mark is less than 80. Check if the mark is larger than 70. Print C, elif, and so on. Let's say all the way you reach the last situation. Elif, else if. It's like a combined word. Elif, else if. So that's why I said like to us we say else if, but in Python to make a shortcut, elif. So let me write the code for this one and let's see the scenarios there. Okay. So input mark equal. First of all, is it integer or float? Let's say if you scored 89.5. Yeah, it is float. Okay, float input the mark. Okay, and let's give it a new line. Yeah, sorry for that. So here I put a new line, I put the mark. Now I'm ready to do the check. How to do the check? If mark is larger than or equal 90, don't forget the colon, print your grade is A. That's it. I'm done with this part. I will check the other case. Is it else? No, elif. Let's go back. Now we see elif. See, the moment you see the color is blue, that's a keyword in Python. So we are fine. elif, and when you hit space, immediately did the indentation. Elif mark is larger than or equal 80. Okay, print your mark or your grade is B. Again, another elif. Mark is larger than or equal 70. Print your grade as C. Now notice like there is a repetition, like once you get it the first time, it is going to be repeated. LF, K mark larger than or equal 60, print your mark, your grade as D. Okay, now if it's less than 60, it's fail, it's F. But do I need to check? All right, like here, my mark is, where's the cursor? Okay, now here, for example, if the mark is larger than 90, do something. This LF means that there is the else part says that the mark is less than 90, but I need to check if it's larger than 80. So I have to check larger than 80 to print B. Same thing here. If it's less than 80 but larger than 70, if it's less than 60, if it's less than 70 but larger than 60. The last scenario, if it's less than 60, do I need to check if it's larger than 50? No, it's already going to be F. So there is no condition to check. So we'll go back to the classical value, just else. Just write else. So always this else part is your default. Else, okay, print your grade is F. And that's it. So always in this kind of multi-branch if statement, the last condition must be with else. Default. Like if the above are all fault or all false, this is the last condition you have. So let's run it. Input mark. Okay, let's say 56. Your grade is F. Another 91. Your grade is A. Let's say if it was at the boundary 90, it is A. 80, still B, and so on. Yeah, we tried with okay, yeah. So right like this, 89.9. Yeah, so this one, like in our case, we do it, we approximate it above. But in this case, the code does not approximate by itself. So it sees it as less than 90. So that's a D. Okay, so there is no rounding up. You can do rounding up. I'm not sure. Yeah, I think later we will do a command like you round up to the next decimal point. Or you round up, you give it like the command is ceiling, I guess, or something. So you round up the mark, then you check on this condition, based on this condition. All right, so this is the case. Yeah, here it does not count the case of D. And the answer is there. Okay, let's see. Now let's see how this one is a little bit different than ours, but still both of them are correct. For example, so the number integer input, enter the number, the numeric grade. So here they put it as integers first, which is still fine. We didn't float, we did it more generalized to count for decimal values. Now, if the number larger than or equal 90, letter equal A. Now see here, is there any printing statement? No. He just created a new variable called letter, and that letter could be A, could be B, could be C. So every time you do assignment based on that condition. However, to display it at the end of your if statement, you have to put a printing statement. So here, if number larger than 90, letter A, LF, number larger than 80, B, LF, LF. And the end, once it's done with all the if statement, print the letter grade is letter. In our case, we did the printing statement within the if statement. So it is perfectly fine. Both of them are correct. So the LF command will make your if statement multi-branch, not just two-way conditional statement. Is it clear? Okay. So that's the model of that one. So that means if it's true, like for example, if condition larger than or equal 90, then if it's true, do this. If it's false, it's less than 90. check if it's larger than or equal 80. True, do the statement. False, it is less than 80, and so on, until you are done with all your cases. Is it clear how the multi-branch if statement or multi-way if statement work? Okay. Now, sometimes you don't have to check, or you cannot say apply only one condition. For example, the mark. Right now, we accepted the mark as they are. Let's say if you put -5, well, still the function, the code will run fine. If you put 150, the code will run fine. Why? Because if the first condition, if mark is larger than 90, print A. If 150 larger than 90, it printed A. Like the condition is fine. But is that, let's say, in real life, is it correct? No, what's the usual, let's say, usual range for mark? 0 to 100. Like your maximum is 100 and your minimum is 0. So in some cases, it's better to check the mark first, if it's a correct mark, then do these statements together. And you will have to do like a if inside if. What do I mean by that? Like the first, the larger if, check if the number is between 100 and 0. Correct, then check these conditions. Then you put an else statement. Now, else not for the inner if, for the upper if, the if that checks if the number is between 0 and 100. Else, just print a statement, or your mark is incorrect. Or the opposite. Check if the mark is larger than 100 or less than 0. Stop there. Then if it's false, if it's wrong, do these conditional statements. So let's see if, how I will upgrade my code right now into like checking between 0 and 100. Okay, so I will leave this code segment here. I may use it later. So we'll do it like this. Again, from the first input statement, mark. Okay, mark equal float integer, enter the mark. Now the first statement, if. What do I need to check? If it's larger than 100. Oh, what? What before less than 0? What did you say? 100. If it's, okay, let's say it in English. If it's larger than 100, or. No, or. That's a keyword in Python, or. So now we're gonna make a compound logical statement. Like you can combine two conditions together. So there is or. What do you think the other one? And. There's or, there is and. So the first condition, if I want to check larger than 100 or less than 0. What about the other one? If I want to do the opposite, I want to check if it's less than 100 and larger than 0. You see like the difference between them? See, now forget about Python. Think about it in real life. So the number should be larger than 0 and less than 100. For me to process the number, to check the values and post the grade based on that value. The other option is to check if the number is invalid, if it's larger than 100 or less than 0. You cannot have it larger than 100 and less than 0 at the same time, but either one of them. You get the idea? Larger than, no. Forget about less than or equal, less than. So that's like an operator, less than or equal and larger than equal. I'm comparing condition to another condition. Larger than or equal 100, less than or equal 0. No. Okay, you are confusing between these many operator. No, this one here, this is one statement. The other one I'm talking about something like this, or, and there is a condition with larger than or equal, and another condition with less than or equal. We may say it like larger than or equal, but this one is different from this one. All right, so let's go back to our code. Now, which one you want to check first? Check if the number is invalid. If mark, what is the first case of being invalid? Larger than or equal 100. Okay. Okay, sometimes you have nerds, yeah. All right, if the mark is larger than 100, okay, and what is the other case? Or or mark less than 0. Now each condition is individual from the other. You let's say, oh, if mark larger than 100 or less than 0, like this. No, each condition is individual from the other. So sometimes that's why I prefer to put parentheses for each condition. Will make things organized, because sometimes you have statements might have 2 or 3 condition, let's say sub statements or small conditions. Why am I getting the X syntax error? You need to put the colon. All right, so if the mark is larger than 100 or mark less than 0, print, well, this is an incorrect mark. So print, okay, so I'll say incorrect mark, values, like a guideline, should be between 0 and 100. All right, else, what does that mean? Now my mark is between 0 and 100. I can apply my conditions. What are my conditions? The ones I wrote here. X, but you have to be careful. It might not give the proper end of the day. It did it fine. Now notice now, this whole if statement, like a whole block, is part of this else. Like this elif belong to this f. This else belong to that f. And I believe that's it. So let's run the code. Let me remove this line. Let's run it. Let's try 95. It is an A. Because basically it will come and check if mark larger than 100, false, or mark less than 0, that's another false. Incorrect mark. So this one will not be executed. It will immediately go to the else. So if mark larger than 5, mark larger than 90, it is print A. And that's it. It's done. Okay, so let's try with a negative value. Negative 60. Incorrect mark, value should be between 0 and 100. You get the idea here? Always before the programming part, understand the problem. So let's write it in another way. My code, check if the mark is valid and do the statements, else print it is invalid. So the opposite of this. And now I'll write it here. So I'll have the same input for mark. And I'll put this one as a separator between them. Okay, now I want to check if the mark is valid. If mark is less than or equal 100, what is the other option? And. We'll come now about the uses of and or. And mark greater than or equal 0. We'll do the statements. There they are. So copy them. Okay. What if my condition here, this condition is incorrect? I should write else. Now see an issue here. Else, it gave an error. Why? You should see the if and else, the matching ones, they have the same indentation. Now this else belongs to what? To which if? To this one or this one? Okay, see this one here, it was already matched by elif and else. This else belongs to this if. You cannot have two else's belong to the same if. So this else I meant for it is what? Is if the mark is not larger than 0, less than 100, which is the negative case, the opposite case. And that's why this else should belong to the previous slide. Else, and I think there is no need for this space. Else what? You put that statement, and correct mark should be, and let's see if everything is fine or not. So there is an error there. Oh, error is gone.
We have two ways of writing the code, right?
See, that's the thing about programming. There is no single way. There are too many ways to solve a problem. Each one has its own approach. Whatever you prefer is fine. To me, what's important is not the code, it's the logic. So sometimes when I grade my paper, some students might have typos in their command. Some people forget the colon in their command. I don't care. Show me the logic. If you know the logic, because in real life, you're not using a paper, you'll be using a computer. In the computer, if you know the syntax, it is fine, but the important part is your logic, is not the code. ChatGPT can do the code and sometimes can do the logic, but for advanced problems, ChatGPT cannot help you on that. So you are the one who need to solve the problem, then implement it with any other programming language. It's not just Python. Okay, let's try it. And hopefully it will work. So input mark, let's say with the 95, it is A. 0 should be F. 105 and correct mark values. So you have seen that there are two ways to solve the very same problem. Okay, let's go back to the slides. So we've seen now the and or. And I believe you've done that in math. And or, right?
Yeah.
So what do you call this table? This table, what do you call it? And this one? Truth table. Well, digital logic design is an advanced level compared to this one. But they took it in math. My experience told me that they took it in math. All right. So in mathematics, you have the and or operations. And remember, now in logic, we deal with only two values, true and false, 0 and 1. Like some people model the false with 0 by 0 and the true by 1. If you do that, that's what we call a digital logic something. That's for computer engineering. They do the digital logic design. Who is the computer engineering here? You will see it, inshallah. Some people already saw it. DLD, digital logic design. Anyways, why they call it digital logic? You have only two values, 0 and 1. All right. So in the truth table, which is written here, in the AND scenario, you can consider AND as multiplication. Do not always do that, just for simplicity. For simplicity, anything you multiply with 0 is 0. So anything ANDed with false is false. So true and true, you'll get true. True and false, false. False and true, false. False and false, false. Anything related with the false is going to be false in the AND operation. In the true, in the OR, now who has the upper hand here is the true. Anything ORed with true is true. So true or true is true. True or false, true. False or true, true. False or false, false. And in many cases, now I will not bring up the and or operations. So let's stick with the commands or and. So those are keywords in Python. There is negation, not, but it's not widely used. However, you need to know how this not works. For example, if you have A larger than B, and then I ask you not A larger than B, what does that mean? What will be the outcome of this?
B larger than B.
لا. لا 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 لا. You do not change the order of A and B. A, B. So if it's not larger than A, if A not larger than B, so it could be equal, it could be less. So it is less than or equal. So the opposite of this, the answer A less than or equal B. Get the idea? So we like sometimes we intuitively say, if it's not larger than, it's less than. No, it could be equal. What about A less than or equal B? And you put not. What will be the outcome in this? No, oh, you negate the equality now. Okay, initially it's less than or equal. So if it's not less than, if it's not equal, it should be larger. So A larger than B. So you have, like, again, you have to think about it, then answer. Don't just give the answer right away. Okay. So those some examples. You can try them at your IDE. So you create a variable called A. You assign the value true. The data type is Boolean. Another thing for B. When you do the AND operation, the result is false. When you do the OR operation, you do true. Not A. Negation of true is false. So the logical operators are evaluated after comparisons, but before the assignment operator. So what we mean by this statement is when we go back to the code, start. Yeah, it says that you evaluate these comparisons first and this comparison first, then you do the OR operator. You do these conditions first, then you do the OR operator, same thing. Now that brings us to another thing. You remember precedence rules. We had math. We done the like indices, parentheses, indices, multiplication, division, modulus, quotient, addition, subtraction, and then left to right. Now, what if I have an expression that have both arithmetic operations and Boolean operations? Where will my Boolean operations fit in the precedence rules table? So if you go here, and here is an updated version of the precedence rules. And it's quite easy that the arithmetic ones will go first, then we do the Boolean stuff. So here, same thing. Assume parentheses on top. You have the indices, exponential. Negation, I told you, is no big deal. Multiplication, division, remainder, and quotient. Addition, subtraction. Then the other 6 comparisons. Less than, larger than, less than or equal, larger than or equal, equal and does not equal. They all have the same precedence. So if they come up in the same expression, which one to do first? I think right to left of this. No idea why, but that's my hunch. We'll check. Then we have the logical negation. As I mentioned, it's no big deal. Then we have the and or. This one is no math, no logic. This is an assignment operator. So basically evaluate the whole expression, then you assign to the variable you want. For example, you have A equal 5 larger than 6 plus 10 minus 15 plus 10 less than 20, etc., etc. All right. So basically, some people think, oh, I have 5 larger than 6, so it's false, plus 10. Oh, that will not work. Right? Now remember, precedence rules, finish the math first. So it is 6 plus 10 that you evaluate first. Then minus 15, then plus 10, then you do the comparison left and right. Okay, so let's see here. A and B is false, then the expression, and there is no need to evaluate. Or B is true, then so that's what we call a short circuit evaluation. Short circuit evaluation, as I told you, when you have like who has the upper hand in the AND operation. I mean by upper hand that if you AND with it, the answer will be immediately there, false. If you have an expression with 5 conditions, and all of them are and one of these conditions is false. Do you need to evaluate the others? Like, for example, I have 5 larger than 2 and 3 less than 4 and 1 larger than 3 and 5 larger than 2 and assume you have a lot of ands and you want to evaluate the result of this expression. Since let's say this one is A, since we deal with logic, the answer I know that could be true, could be false. So this one, 5 larger than 2, it is true. 3 less than 4, it is true. 1 larger than 3, false. Do I need to evaluate this? I have and all ands, and I'm ending with a false. A single false gonna make the whole expression without need to evaluate the other expressions. Get the idea? So that's what we call a short circuit or a smart way of solving a logical operation or a logical statement. Okay. So sometimes when you run a conditional statement, make sure that all possible branches or alternatives in the selection statement are exercised, meaning that if there is a true case, there is a false case. So check all possibilities, or in the multi-branch statement, check all possibilities that you have. After testing all the actions, examine all of the conditions. But sometimes when you run the code, you might get an error. So check, did you cover all cases? If they are all covered, then check your conditions. Probably you forgot an equality sign for less than or equal, you put less than. That could be one of the issues. So check all of your conditions. Now check the compound statements using the data that produce all of the possible combinations of values. So usually when you do testing, you test with all values. Like in our case, when we did the marks, we did with a case larger than 90, we did the case with a larger than 80, we did the case with a negative number, we did the case with larger than 100. And all these use cases provide that desired output. So then in that case, the code is fine. I cannot claim that the code is fine if I did not test all use cases. Okay, so in summary, Boolean expressions return only true or false. Logical operators and or not. Python use short circuit evaluations. So selection statements enable programs to make choices. If else is a two-way statement, else part is optional. You can have a perfect if statement without the else. You can have a multi-branch if statement with or multi-way if statement and so on. I believe this is the last slide. Let's go back to the operations here. Okay, let's try to evaluate this expression and confirm with the spider. As I mentioned, we do the math first, then we do the logical operation first. So here, I have 6 plus 10, 16, minus 15, that is 1, plus 10, that's 11. So then my condition 5 larger than 11, less than 20. That's not even applicable, actually. There should be an and or. Yeah, the expression is incorrect. You cannot have something like this because the result of this is what? It's going to be either true or false. And then false less than 20, I don't think that command will work. However, in the exam, could be an and here, for example, and then in that case, you have 5 larger than 11. It is false, and it with probably another expression here, because the and should be with logical operations. So yeah, this is a wild example from my mind. This is not a proper one. Let's see what examples I can give for this. Like for the if else statement, that's probably the highest level of examples I may come up with. Okay. Let's say you are running a renting car company. This card. And in that rental car company, that if you rent for 10 days, up to 10 days, you get a certain rate. And if you rent between 10 to 20 days, that's another rate. And beyond the 20 days, that's a different rate. So let's see. Okay, so let's see here, duration. I'm gonna make a table and rate. And if you rent for up to 5, up to 10, or like this, less than or equal 10, you will get the rate 500 per day. Rent per day. And if it's larger than 10, and less than 20 as the days, the rate will be 400 per day, or 450. Let's be realistic. 450. But if you are renting larger than or equal 30, 10, 20, now we have to cover the case of 30. Larger than 20. Larger than 20, they'll give you the rate of 400. So this is a car rental company giving an offer that if you rent more than 20 days, you'll get this rate of 400 dirhams per day. If you are renting between 10 to 20 days, that's 450 dirhams per day. If you are renting for only 10 days, that's 500 dirhams per day. So write a Python code that determine the rental amount of the car. Do you know the number of days? No. Do you know the rental amount? Well, that's what we want to calculate. What about the rate? It is a variable, changes based on a certain condition. So first, what are you going to ask the user to input? The number of days. Because based on the number of days, the rental amount will change. Okay. So let's write it here and then apply it into Spider. The number of days, is it integer, float? Integer. So days equal integer input, enter the rental duration. Like the amount of days you want to rent. Now, if days is less than or equal 10, what will happen there? On the rate, right? So rate equal 500. What is the other thing? Elif. Now it's a multi-branch. See, the moment you see 3 choices, that's multi-branch. Elif. What's the other condition? Less than or equal 20 equal 450. Elif. So I'm done with this one. I'm done with this one. The last case, else. Rate equal 400. What is the last part? Print what? Let's keep it simple. Let's keep it for the number of days. So let's assume that I put, so probably you want to check if day is larger than 0 and then do the others. If I put a negative number of days, then, but let's keep it simple. Let's keep it this way. I need now to find the rental amount. How do you calculate the rental amount? By the day. So we found the rate. We know the number of days. What is the rental amount? So rental amount That's an underscore. Underscore is acceptable in Python or all programming languages. Rental amount, basically, it's going to be the daily rate. So rate times what? The days, the number of days. So if you rent the car for 20 days, then you pay 400 dirhams per day for 400 times the number of days. And then do this rent, whatever, rental amount. Okay, so let's write it real quick on Python. Okay, days equal integer input, enter the number of rental days, and then if days is less than or equal 10, rate or daily rate equal 500, elif days less than or equal 20, then the rate equal 450, else rate 400. Okay, then rental amount, it is important to change the indentation, because if you put it here, your code is fine. Rental amount equal days times rate. You see, there is no error. However, this line belongs to this else, so it will only be executed if the number of days is larger than 20, because that's the last condition, else. But if I take it to this, to the beginning of the line, I'm beyond the if statement. I'm out of the if statement. So indentation tells you where your statement belongs to. Next week, inshallah, we'll do loops. It will be there. Indentation is a very important thing in Python. Sometimes mistaking the indentation will change the structure of your code. Syntax is fine. Runtime is fine. That's a logical error. That's one kind of the logical error that gives you a wrong answer, that you misplaced the statement in the wrong location in the code. Okay, then print total rental amount, quotations, comma, and rental amount. And let's give it a new line, actually. Okay, so let's run it. The number of days, let's say I'm renting for 15 days. 15 times 450, how much? And do the math. Okay, so I'll give a new line for this one also. 15 times 450 is going to be 6,750. Let's try with 5 days only. 5 by 500, 2,500. Let's check the difference between 10 and 11 days. 10, so it's 5,000 dirhams. 11 days, 4,950. So if you rent a day more, you'll get cheaper. Yeah. It's a wrong business model, but just get the idea. Okay. That's pretty much it. If there are more questions in my mind, we can, let's say, discuss them. I'll send you, let's say, what kind of exercises you need to be aware of. But yeah, that's it for today. The lecture is quite simple. You need to practice more into writing if statements. Let's see. I remember long ago, I found an online source for like a lot of questions for if statements. I will look for that resource and share it with you. And that's it. So I'll do the attendance. Let me stop sharing. and stop the recording. Stop.